Hello everyone, I'm Suraj from Sri Venkateswara College of Engineering. Today I'll be discussing about a topic called minimization of DFA, which comes under automata theory and compiler design. First, coming to minimization of the DFA. As the name suggests, minimization, which means to reduce something to the smallest level or amount. In automata theory, a branch of theoretical computer science, DFA minimization is the task of transforming a given deterministic finite automata into an equivalent DFA that has the minimum number of states. Now, let's come to the steps to minimize that given DFA. Suppose there are two states, consider them as P and Q of the DFA that are equivalent if and only if row of P, W and row of Q, W are leading to final states. So why we need to minimize the DFA? For each regular language, there also exists a minimal automata that accepts a DFA with a minimum number of states, and this DFA will be unique. So we need to minimize the given DFA. For minimizing the DFA, we use the table filling algorithm. Now coming to step 1, we remove all the non-reachable states. These non-reachable states are the states that are not reachable from the initial state of the DFA for any input string. These states can be removed. Next, step 2. For each pair P, Q, where P belongs to Q and Q belongs to Q, if P belongs to F and Q does not belong to F, or P does not belong to F and Q belongs to F, then mark the pair P, Q as a cross symbol in the table. Next, the step 3. For each pair P, Q and for each symbol A belongs to summation find row of P, A equals R and row of Q, A equals S. If the pair R, S is not in the table, then mark the pair P, Q with a cross symbol. What we do in step 2 and step 3 is we basically mark the nodes. If one node is final state and the other node is non-final state, then we mark it as a cross symbol in the table. If both the nodes are final state, then we do not mark anything. If both the nodes are non-final states, then also we don't mark anything. Now, here what we do is, in step 4, we repeat step 3 until no more marking can be done in the table. At last, we combine the unmarked states to get our resultant DFA. Here we take the following example for explaining the minimization of the DFA concept. This figure contains Q0, Q1 and Q2, the three states. Q0 is the starting state, or it is also called as the initial state. Q0 has a self node B, and on A it goes to Q1. Q1 has a self node B, and on A it goes to Q2. Q2 on A it goes back to Q1 again, and Q2 has a self node B. Q3 on A it goes to Q1 and Q3 on B goes to Q2. Here Q0 is the initial state, Q1 and Q2 are the final states. We see the solution of the given figure now. In step 1, what we do is we remove all the non-reachable states that will be present in the given figure. In the given figure, as we can see, Q0 on A goes to Q1. In the same way, Q1 on A goes to Q2 and Q2 on A goes to Q1. But what we see here is from Q1 none of the inputs goes to Q3, and from Q2 also none of the inputs go to Q3. We can figure it out now that Q3 is a non-markable state, non-reachable state, and it is removed from the given DFA. After removing Q3, we get something state like this. Here we have Q0, Q1 and Q2, but Q3 is removed from the DFA. Now in our DFA, we are left with only three states, that is Q0, Q1 and Q2. In step 2, we need to create a table something like this, which consists of rows and columns. Horizontally, we mention Q0 and Q1 but do not mention the final state, that is Q2. Vertically, we mention Q1 and Q2 but do not mention the first state, that is Q0. Vertically, we don't mention the first state, and horizontally, we don't mention the last state. Now what we need to do is, we need to fill the table with cross symbols. As I've earlier told you that one state should be non-final state and the other should be a final state. Then only we can mark the table as a cross symbol. Now let's check the first state, Q0 and Q2. Q0 is the non-final state, but Q2 is a final state, so we mark it as a cross symbol in the table. Next, Q0 and Q1. Q0 is a non-final state, but Q1 is a final state, so we mark it as a cross symbol. Now we check the further states which can be marked with a cross symbol in the table. We create a table consisting of row A and B, and we take the square which is not marked, that is Q1 and Q2. Here Q1 and Q2. Q1 on A it goes to Q1. On Q1 on A it goes to Q2. So Q2 is written here. Q2 on A Q2 on A it goes to Q1. So Q1 is written here. Q1 on B goes to is a self node. So Q1 will be remain as the same. Q2 on B goes to Q2 only as it has a self node. So this cannot be marked as Q1 and Q2 both are the final states, so this square is left out empty. It is not marked with any of the symbols. Next, Q0 and Q2. Q0 on A goes to Q1 and Q2 on A goes to Q1 again. Q0 on B goes to Q0 as it has a self node, and Q2 on B goes to Q2 as it has a self node. So this state is marked as one state is non-final state and the other is a final state. So it is marked in the table with a cross symbol. Next is Q0 and Q1. Q0 on A goes to Q1. Here as you can see, Q0 on A it goes to Q1, and Q1 on A it goes to Q2. Q1 on A it goes to Q2. Next, Q0 on B goes to Q0 as it has a self node on it, and Q1 on B remains in Q1 only as it has a self node. So this state is also marked as one state is a non-final state and the other state is a final state. Now, every combination of A and B is accepted by Q1 or Q2. So Q1 or Q2 together can be collapsed into a permanent accept state, and now the diagram becomes something like this. Here Q0 is taken separately, but Q1 and Q2 are together taken. It is encircled with double circles as Q1 and Q2 both are the final states. Q0 is the initial state. Q0 on A it goes to Q1 and Q2. On B it stays there only as it has a self node in it. Thank you everyone. I hope you understood all the concepts that are covered in this presentation and hope you enjoyed it. Thank you.